session of Thoth demo. Today we're going to see an update on jupyterlab-requirements package that Project Thoth introduced. And specifically, we're going to talk about a new feature that was requested. Basically, as a user of jupyterlab-requirements, there would be a need to have a CLI, and the CLI would allow for specific checks or verify the content of the notebook and create the kernels, so everything that is related to the notebook reproducibility itself. And this can be applied, for example, to CI. You want to verify that the notebooks is reproducible, that has all the dependencies, that has been that contains a pip file and pip file log. And so we introduce a new feature, and we call it Horus. So Horus is another Egyptian god, so part of Thoth family. And this CLI called Horus is specific for jupyterlab-requirements. So this CLI basically allows you to interact with the notebooks. So the input will always be Horus, a certain command, and the basic mandatory input or parameter will be the notebook itself. So right now we can handle only one notebook at a time, but maybe in the future, if required, we can extend that. But there are several commands that have been introduced. We can go through them one by one. So after you install jupyterlab-requirements on a version higher than 0.9, then when you run Horus, you will basically see this CLI. So Horus is a CLI for jupyterlab-requirements. There are some common options if you want to see like more details on what is happening on the background. And then there are several commands. So the first command is basically a check. This check command will verify that the notebook contains everything related to dependencies. So let's have an example. I created a repo where there is empty node, so there is a notebook empty with nothing. So if I run Horus, this notebook, then you can see that the check will show the kernel name that is present, if there is any dependency resolution engine key, which basically identify if the dependencies have been locked with some specific resolution engine, either Thoth or pipemp. And then it looks for some specific key that contains the actual pip file and pip file log. So in this case, as I said, this is an empty notebook. There is nothing there. And this will basically show you what is missing. So let's say that now I want to add some specific requirements to my notebook. So what I can do Horus requirements and always consider this notebook. And let's say I want to add a specific package, then I can do add photo 3, for example. And now you see that this pip file has been added to my notebook. So if I run again, run check, see now there is a specific pip file created. What you miss is basically the log file. So in order to do that, you can run basically Horus log. Horus log has several inputs, depending if you want to use Thoth or pipemp. Most of the input parameters are specific to Thoth. So you can basically select the recommendation type. If you want to force the request to the advice, if there is an existing advice result, you can select the timeout for the advice request. And actually, you can also select the runtime environment you would like to use. So in this case, for example, this has been created discovering what is available on my system, which by default I have Python version 3.9. But let's say that I want to lock the dependencies, and I actually want to use Python version which is 3.8 actually. So let's try. You can see the resolution engine selected was Thoth. Python 3 kernel name is not something that we can use, because by default we don't want to overwrite the default. So we assign basically default kernel name that can be also stated by the user if they want. And then there is a runtime environment which is used to ask Thoth for a specific recommendation. And as you can see, in this case, is using what is have been identified from my host, from which is the 33 exactly. And as you can see here, there is no more Python 3.8.9, but Python 3.8 because something that was requested. And basically, after Thoth will provide the result, then everything will be stored in the requirements log. But meanwhile, we can have a look at another example. So let's do Horus check on a specific example. We know that there are notebooks here, so let's start with this tutorial. For example, there are 3 notebooks: the training notebook, the download data notebook, and the download dataset notebook, and the test deployment. So let's try the download. Basically, we can check for each of them if everything is correctly created for these notebooks. If you try the training one, you can see that also this notebook is everything correctly handled, so they have all the inputs required. And in this way, we can basically verify that the notebooks are reproducible because all the dependency content is there. And as we showed before, Horus has other commands. Discover is basically a command that relies on Thoth Invectio library. So if you run discover on a certain notebook, then you can basically read the content of the notebook and try to identify what are the dependencies for the notebook. So imagine that you have a notebook which was never created with the jupyter-lab-requirements, and you want to embed the dependencies in your notebook so you can share with someone else. And in order to do that, you can basically run Horus discover. Let's say that I want to do that on the training notebook that I saw before. Notebooks training, and I want just to show how the pip file would look like. So I can run show only option. And as you can see, this is actually what Invectio library identified. So in order to run that notebook, you need the TensorFlow, NumPy, Matplotlib, and Boto3. So in this way, we can help anyone that never used jupyter-lab-requirements to have basically an easy way to discover the dependencies. The dependencies sometimes might not be exactly identified, so the user still needs to have a look, but this is basically a way to help them. And after that, as you saw before, you can run the lock. If Thoth for some reason might fail, then you can also request, for example, also pipenv. So we give an option if something is not working to still obtain the result. And once you have the discover, then you can lock the dependencies. And as you can see here, this finished. We can check the notebook contains everything now. You can see at the beginning we were without anything. Then we added one specific package. The pip file was correctly saved. And then we lock the dependency. So now you see that the kernel name is jupyter-lab-requirements. The dependency resolution engine was pipenv. And the requirements key, requirements lock are present and correctly saved. The hash between the pip file lock and the pip file is correctly saved. And then basically we check the available kernels on the host and verify that they are suitable for your environment. If not, if that is missing, then we can basically use a specific command called Horus set kernel. This will basically create the kernel, install the dependency in there using micropipenv, and then you will have the environment ready for your notebook. So let's try. We can do set kernel to this specific notebook, and we should have a new kernel called jupyter-lab-requirements. So as you can see, basically took the dependencies that were saved in the notebook, and now is installing them with micro-pipenv. And at the end, we'll basically check the kernel. We can check the kernels using the kernel spec command, Jupyter kernel spec command. And as you can see, there is actually the new kernel. So you can see that everything is saved, and you also have basically a kernel that you can use. What other commands we missed for this presentation? So if you want to check, for example, the version, we also show what is the Thamos and Thoth version, because most of the logic that you see is built on top of Thamos, which is the integration of Thoth, the official Thoth CLI extension for any Python project. We adapted basically the Thamos one to work for the notebooks. So if you do Horus version, you can see, for example, the Horus version, and in this case there is no, because there is no API information because there is no Thoth configuration file. But if we go to some specific repo where release the Thoth configuration file, then we can take basically the information also regarding the API. So you see the version. So what other commands we missed? So there is extract command. So in the extract command basically is able to extract whatever is in the notebook metadata in terms of dependencies, so the pip file lock, and then you can use this pip file lock for other reasons. For example, if you want to build an image to run this notebook, then you can extract this content and then install them and use them for creating an image. Save is the opposite behavior. So if you have a pip file lock that you created for your notebook and you want to store them in the notebook, then you can do the save command and show basically show what is available in the notebook dependencies, of course. So if I do show notebooks training, see that in this case there was no Thoth configuration file, but there is a pip file lock saved, and there is also a pip file, which is what we saw before. So I hope you find the CLI useful, and in the next actually weeks, we want to introduce magic commands. So the CLI from the with the basically built-in magic commands of Jupyter. So in this way, you can either work from the UI. You can use the CLI for specific automation processes. Maybe you want to check the notebooks that you put in another environment, or that you use to run a specific logic, that they contain everything that you want in terms of dependencies, and that they are reproducible. Thank you very much. If you have any questions, please reach out to us. Open issues if you find any problems in jupyter-lab-requirements, and we are always happy to receive new contributions, especially for the UI part, because the one that needs still a lot of improvements. But in any case, thank you very much for listening, and see you next time. Bye.